So this is the model building assignment. So for the assignment for the online kids, you are not going to be taking pictures of the models you build because I can't get the model kits to you, but those hybrid students that are going to be working in class can take pictures of the four. When you do this, I want you to take pictures of all four of them at one time, so you're just submitting one picture. I'd like to put not a screencast, but like an actual little movie of me showing you how the models go together then for the online students, so you get to see the benefit of at least seeing it. But I'm working on that. I need a whole like producer and director and stuff. So let's take a look at this. So this is recording your observations, the compound, electron domain geometry, and molecular shape. To be able to do electron domain geometry and molecular shape, you need to write the Lewis structure. So let's go to the Lewis structures. Okay, so for the Lewis structures here, for number one, I have H2. H2 couldn't be easier. We know that when we do this, we have one H here, we have one H here. These two are going to connect. That means I have this. Okay, when you have two or you have three in line, that's always going to be linear. Okay, so when I go back to doing this, there we go. It's going to be linear, and there are no non-bonding pairs for this, so it's going to be linear again. Okay, so when you have only two, like HBr or H2, then of course it's going to be linear. So let's go back to HBr. HBr has 1, Br has 1, 2, 3, 4, 5, 6, 7, like that. The two single electrons are next to each other, so we bond there. Again, this is going to be linear because there's only one bond in between the two, and it's going to be linear again for a molecular shape. Okay? I'm going to do it like this instead of flipping back and forth because now I got to scroll down to these. So let's take a look at number 3 is H2O. You've seen this one several times. Oxygen ends up being the central atom, and one of the reasons why is because hydrogen and fluorine are terminal atoms, which means that they can never be the central atom. So I have 6 valence electrons for oxygen, which means I'm going to look something like this, where I have a single electron, and then lone pair and lone pair. That means that my hydrogens then are going to end up being here and here. Now, the problem is that with the Lewis structure, you make it look like, or it can look like, with the Lewis structure that we could end up with oxygen looking like this, and hydrogen like this, and you're saying, well, why is this not linear? Well, it can't be linear because when we do the electron domain geometry, we count the number of electrons, the groups, whether they're pairs or whether they're non-bonding pairs or bonding pairs. So this would be 4. So 4 is tetrahedral. Okay, so tetrahedral for the electron domain. That's an A. Good. And now I count the number of non-bonding pairs or lone pairs, and that is 2. So if I have 2 for tetrahedral, that gives me bent. Take a look at this. This shows us here. If I have 1 bond or 2 bonds, that is linear. If I have 3 bonds that are bonding, that is, and no lone pairs, that is trigonal planar. If I have 4, like I do with oxygen, and 2 lone pairs, well, I should circle this one. This is the one that's 2 lone pairs. Okay, then I have bent. It looks like this, and there's my example. Okay, so I go back here. My electron domain geometry for number 3 is tetrahedral, and then because I have 2 non-bonding, that means it's bent. Okay, so that's how I'm answering this. So let's keep going. So what do we have for NH3? Well, NH3, the N, remember H is a terminal atom, so I have N looks like this. Those single electrons are perfect for bonding for hydrogen. So I bond there, and I bond there, like that. How many electron domains do we have? We have 1, 2, 3, 4. Again, for electron domain, this is tetrahedral. And the number of lone pairs is 1. So if you have 1 non-bonding, that would be trigonal pyramidal. Where am I getting this name from? It's actually, I'm getting it from right here. So I go down to tetrahedral. When you have 4, I have 1 non-bonding, so that's trigonal pyramidal, like that. And there's NH3 as my example. So let's go back and see what else we have here. Now sometimes you may end up with more than one central atom, and that's okay. Carbon is always a central atom, nitrogen's also always a central atom. So if I have carbon, I make it look like this, 1, 2, 3, 4, like that. Because I know a lot about carbon and the compounds it makes, I'm going to put nitrogen right next to it, and I'm going to do nitrogen looks like this. That's how I typically do it. I'm already going to make a bond between the carbon and the nitrogen. The rest of these for carbon are going to be hydrogen bonds, like this. That's why it's written like this with CH3, meaning 3 H's are attached to the hydrogen. I have 2 more open spots for H's for nitrogen, and that's left altogether. Now, if I'm looking at the electron domain geometry for the carbon, the first carbon, that's going to be 1, 2, 3, 4. So that's going to be tetrahedral. And because there are 0 non-bonding, that's going to be tetrahedral again. Okay, so for carbon, it's tetrahedral, tetrahedral. For nitrogen, I'm going to count 1, 2, 3, 4, which means that I have, for nitrogen, I have tetrahedral, because there are 4 electron domains, and for the molecular geometry, I have 1 lone pair, 1 non-bonding, which means trigonal pyramidal. Okay, so I have more than one central atom for number 5. I have the carbon, and then I have the nitrogen, and you have a place, if you take a look back here on this worksheet here, this would be for electron domain geometry, this would be tetrahedral, and for the molecular shape, because there are no non-bonding, it would be tetrahedral again, and for electron domain geometry is tetrahedral, and then for trigonal for nitrogen, the molecular shape would be trig pyramidal. Okay. Last one. This is the one of the reasons why I like to do this one as an example is because this is the first time we see something other than a single bond. So this is CO2. We know that carbon is going to be our central atom because carbon is often our central atom, like that. I have an oxygen here. I set this up specifically like this so you can see the first bond like that, and then there's a second bond that happens there. I set up the other oxygen to be like this so you can see the first bond there and the second bond there. And what ends up happening is I have a Lewis structure that looks like this. Electron domain geometry is 1, 2. 2 is linear. And because there are no non-bonding, 0 non-bonding, that's going to be linear also. Okay, and that's it. Good.